Hi, this is Chris, and the subject of this video will be defining and assigning supports and springs. We'll talk about four major topics in this video. We'll talk about the supports command, the support data table, the springs command, and the spring data table. We'll use a mesh of finite elements in this video just because that provides us with some plates as well as a whole bunch of nodes so that we can demonstrate some different types of supports and springs. So let's look at the supports command. I'll come up to assign properties and then down to supports where we get the assign supports dialog. Starting at the left, we can see that we have three different kinds of standard supports. We have a pinned support where the degrees of freedom are set so that translation in the global X, Y, and Z are fixed, but rotation about X, Y, and Z are free. Notice that we have an option to assign entities to currently selected nodes. I don't have any selected, but the assign supports command is a little bit unique in the sense that if we don't select this checkbox, but we do click the assign button, notice that we get this special cursor. And if I use that cursor to click on a node, it assigns the selected support type to that node, and it shows us a nice graphic that's representative of the type of support that we're working with. What I'll do now is I'll right-click the mouse to release that command, and then right-click once more to bring the pop-up menu that allows us to repeat the last command. And now notice that we're back to the assign supports dialog. So we took a look at a pinned support in that case. We also have a fixed support that fixes all 6 degrees of freedom, or a roller support that allows some translation in the X and rotation about all 3 rotational degrees of freedom, but just fixes the Y and Z direction translation. And again, if I click the assign button and pick on some node, we can see that there's a graphic distinction between a pinned and a roller support with those little rollers underneath it that tell us that it's a little bit unique. Right click twice, repeat last command. Now what we can do is look at the category that's referred to as others. These are the unique types of supports that you can customize. So as soon as we select others, notice that the fixities for certain global degrees of freedom become enabled, and we can select and deselect whatever we want to create here. If I select something like fixed in the X and fixed in the Z, and then assign it to a particular node, notice that we get a different kind of graphic. You can think of it as an arrow, and what it's trying to show us is that there's resistance to translation in the global Z direction, and there's also one that's resisting any translation in the global X direction. If I come back and modify that just a little bit by indicating that we don't want to allow any rotation about the X or rotation about the Z, I'll assign this to a neighboring node. Now we can see that it's a similar graphic with the arrows that show resistance to translation, but they also have these small vertical bars, and those indicate a resistance to rotation about the named axis. I'll right-click twice and repeat the last command. So the last thing that's available to us in this assign supports dialog, specific to the other type of support, is what they refer to as enforced displacement. So for any degree of freedom that I've declared to be fixed, I can also come in and I can specify an enforced displacement if I want to, and I might have something like -1 and -2. I'll assign those. What this will let us do is segue into the supports table, where we'll be able to see the fixed degrees of freedom as well as the enforced displacements. So what I'll do is come to tables and then down to supports data. Here we can see columns that list all the supported nodes, the supported degrees of freedom. Note that a 0 in this string indicates a free and a 1 indicates a fixed or restrained degree of freedom. And they're listed in the order of X, Y, and Z translation, and then rotation about X, Y, and Z. So that's the syntax for that string. And then in the remaining columns, we can see any enforced displacements. And notice here's my enforced displacement that I happen to assign to node number 1. It was a displacement of -1 inch in the X direction and -2 inches in the Z direction. So that's a look at supports. The other thing that I'd like to mention is in this support data table, it is something that can be edited. So if I wanted to put in a rotation of 2, we'll say, I can just enter that and then click onto another cell, and that will be applied as well. The other thing is that we can select these rows and then use this button, Cut Selected Rows, to remove the selected supports, and then when I say OK, they'll go away. So that can be handy, generally not to remove all supports, but maybe to remove selected supports in your models. What it does for us, though, is it sets us up now to talk about springs. So I'll come to Assign Properties, and then down to the Springs command. And notice that the first decision we have to make is, do we want to apply nodal springs to selected nodes, or do we want to apply line springs to selected members, or are we referring to surface springs? And those would be applied to shells. If you're working with nodal springs, notice that all 6 degrees of freedom are available, and that the program collects a spring constant for each of those 6 degrees of freedom in the specified units. The other thing to note is that when you're working with springs, you have the nonlinearity option, which allows you to specify perhaps a compression-only spring, like we might use on a matte foundation. There is also an option to do a tension-only spring, if one is necessary, and then to restore things to something that would resist both tension and compression, you can select the linear option. So what we might do as an example here is we might specify a surface spring. This command works similar to the other one in that it does give us a cursor that allows us to click on individual nodes afterwards, but in anticipation of the fact that I'd like to apply a surface spring to the mesh of shells, I'm going to just come back and do Control A and turn off that material designation. Then I can use Assign Properties Springs, indicate that this will be a surface spring. I'll just put in some values here. And notice that a surface spring only allows an assignment to the 3 translational degrees, and it's in units that are pressure per length. So you can think of this as KSI per inch, if you want to think of soil pressures. So with the option set here to assign this to currently selected shells, I'll just click the Assign button, and we have a whole bunch of springs that have been assigned to our mesh. We can clarify that a little bit by coming to Settings, Graphic Scales, and in the Support Spring category, we might use a value of something like 0.75, and then say OK. That starts to clarify things, and that can be adjusted even further if you needed to clarify the view even more. So the last thing we'll do is come to Tables and then Spring Data. And notice that we have 3 different options: a nodal spring table, a line spring table, and a surface spring table. We've only applied surface springs, so we'll view that table. And it's similar to what we saw for the supports table. We have a list of shells that have had springs assigned. We have degrees of freedom listed. Notice that a 0 represents a linear action, a 1 represents a compression only, and a 2 represents a tension only. And then we have stiffnesses that have been assigned. So a stiffness in the X direction, the Y direction, and the Z direction. So hopefully that's been a helpful look at defining and assigning supports, as well as defining and assigning springs in ENERCALC 3D.